Now in this session we are going to understand what is meant by linked list. So linked list basically means, so we have already know what is meant by array. So array we have already seen, we have to initialize the size first itself. If you know don't initialize the size, it will be going to give an error. Or you have another option called array list, that is known as dynamic array. We have this concept in C++ language also. So this dynamic array will be used in the, if you according to your requirement. So other than that, we have another concept called linked list. So it is a quite opposite of the array and dynamic array. So what this linked list will do, that we are going to uncover all the stuff in this video. So basically we can read this definition over here: a dynamic node based data structure where elements are linked by reference, means pointers, not continuous memory location. So we already know array means the continuous memory allocation will be allocated for all the data that you are storing, and you can only store one type of data. In the linked list you can store one type of data, that's your wish, according to your wish. But the main important thing here is it's not continuous, guys. You can see here, so not continuous memory. So as this is not continuous memory allocation, you can have the memory random access. So with this, what you can have the addition. If you want to add the data in between, if you want to delete the data in between, so this is somewhat faster as compared to the array. But the searching operation, if the searching operation is very slow in the linked list, because so in the linked list we are going to search node by node, so that will take time. But in the array, that is array based indexing. So if you know the index, that's it. We can say that array, the element is particular element is present in that or not. So if you see that only here we have two types of linked list, that is singly linked list. Here LL means the linked list. So we also have another kind of linked list called doubly linked list. So in the singly linked list we have the two nodes, that is data part and next part, and this next part is connected to the next part of the node. So this same node is replicated here, the same node is replicated here for the different data. Here we have another data, we have other data, another data. So at the last node, the next pointer will be pointing to the null. So here the next pointer is pointing to the next node, like that it will be all the linked list will be over there. So why we call this as linked list? Because the this data is linked to the next data, this data is linked to the next data. So this is like a chain or a list. So that is why we call as this is as linked list. So this is the first node. How can we know as this is the first node only? We should have another pointer as this is same. So that is known as head. So with the head pointer as the same as this one, but both of them will be the second next pointer will be null, and the head pointer will be pointing, the data pointer will be head, that will be pointing to the first node of the singly linked list. Okay. So the similar concept we have in the doubly linked list as well. So in the doubly linked list, so we can also traverse backward. So in the single linked list we can only traverse forward way. If you want to traverse at a time forward, backward in a single linked list, so we can achieve that with the help of the doubly linked list. Okay. So there are two types of implementations. They inbuilt we can implement in the Java. We have the linked list class. So with that we can implement, or we can use, or we can build inbuilt linked list by ourselves. So now we will understand what is meant by array list in Java. So array list we have already discussed. It is just extension of the array. So this array list is also known as the dynamic array in C++ language. So in Java we call it as array list. So if you read the sentence over here, it says array list uses an array which allows for fast random access but slow insertion and deletion. Because if you want to delete, so if you want to insert or delete in between, so you need to shift all the data, all the indexes you need to shift, and in between for inserting one data in between. So that's the main drawback of using arrays and dynamic arrays. It's just the array. Suppose it's just the array, then what is the use of this dynamic array or the array list? So basically, if you observe clearly, I have an array called AL, which is of size 10 in this case, from 0 to 9. So suppose after filling all this stuff, you want to insert the 11th element. How can you insert that 11th element? So for inserting that 11th element, you need to have the extra space, but we do not have. But don't worry, in the dynamic array, what we are going to say is, so with the help of these old values, we are going to copy. With the help of these old values, we are going to copy all these 10 values to the another new array. But here we have extra space now. So this is known as the dynamic array. So you are not going to manually create this one. The Java itself will be going to create this dynamic array, the bigger array, copying all the stuff here for you. You just need to create this one. You just need to create AL. So inside that automatically it will be going to create this one whenever you trying to insert the 11th element. So this is known as dynamic array. Here also you can see the same stuff, 10 elements, but after filling the stuff, after filling half of that, so not that 10 elements, after filling half of the elements only, you can see over here, after adding the 7th element, a new array list is created with capacity 20. I hope this makes now some sense. So as the full capacity is there, but if you have the capacity half more then it will be going to create an extra size. So extra size of the size double than this. So this is known as array list. So but this is also somewhat like array. The index is faster, you can see. So allows faster in random access but slower insertion and deletion. If you want to delete this fourth option, you need to shift all this stuff towards front for the single operation. So for that purpose only we are going to use the linked list. So linked list is faster if you want to delete and if you want to insert data in between. So after that we need to understand where this linked list is present inside the collection. So we already know collection interface is an interface. Here you can see. So basically we cannot able to declare the function inside this interface, or we cannot able to create an object for this interface in Java. So basically this collection is implemented with the help of this list. So as this list is failed to implement this collection interface, so it also become an interface. So this list is now implemented with the help of this array list, okay, or this list is implemented with the help of this linked list, okay, or we can use this queue interface. That data structure we will be going to explore in this session, in the sessions in this DSA only. This key also important, okay. We are understanding now this linked list, or you can see simply with the help of this diagram as well. In this diagram what they are trying to say is basically this diagram and this diagram is same, but you can see the green color represents the interface and the blue color represents class. Here you can see the linked list, array list, vector, stack, these and all stuff is the basic data structures in the DSA. So this and all will come under the interface list. So this interface will be implemented with the interface collection. So I hope this makes some sense now. So we have also the interface queue. This interface queue will be implemented by the queue collection. So this the queue interface will be implemented by the collection queue, okay, collections, okay. In this we are going to have priority queue, booking, blocking queue, and all this stuff, okay. I hope this makes some sense now. So we are going to see the hash set is a class which is implemented by the interface set, and this interface set is implemented by the collections interface. So overall we can say this collection is an interface which implements all these three stuffs, or in this only the linked list is a subset. So we understood what is meant by linked list. Now we are going to understand how we can add a node. So basically this is the node structure. We have data part and the next part. So this is known as node, okay. So what we have to do is we need to add at the end. So you can see we have a head pointer that is pointing to the first element, to the first address. Now what we need to do is we need to add this new node at the end. For that we need to have a new pointer that is same as the head, that is which is the same address 100, which is pointing to the first element of this linked list. So with this current pointer, what we can achieve is I will be going to explain now. So first of all, point this current pointer to the first node, and you need to make this new node and fill the data and the next with the null, okay. Ready, keep it ready. So after doing that, so don't move this head. If you move this head, you are going to lose this first node. So if you want to traverse the whole array, you need to definitely have a current pointer. So after having this current pointer at the end of this, so next you need to append this new node here. Then how can you move from first node to the last node with the help of this current pointer? Basically you can use while loop. So you can see how I used while loop here. So inside the while loop I am checking while current dot next not equal to null, means that, so as first current is here, you can see current is in the head. So current dot next means the current next is here. So current dot next means it is pointing here. You can see 105. So this is not equal to null. So you can able to move from here to here, that you can see here. So it is moving from here to here. How it is moving? It is written over here. So current is equals to current next. So basically you are moving from current is equals to first current next. What is current next? 105. So first current will come here. So after that it will again check. It is again not equal to null, that current dot next. No, it's not. So it again comes here. So then again we are incrementing that current is equals to current next. So after this current pointer pointing to the last element in the linked list, the next step we are going to do is with the help of this statement we are going to add the new node here. So what is that statement? The current node is pointing to the last one, and we can simply say current dot next is equals to new node. So simply this current dot next is equals to new node, that's it. So there is no need of making any other connections, that whole connections has been made. So this is how you can append any new node at the last of this thing. So adding a node at first. So before seeing this, let us see practice. So I currently in my VS Code, what I am going to do is, so first I am going to show you how you can use the inbuilt linked list. So this is the inbuilt linked list, which is coming from the java.util.linked list. Okay. So basically if you hover that, it will be going to say as linked list is the class. Okay. So we are going to have a linked list. So in this linked list, we are going to mention the type of the thing that we are going to store in the linked list. So I am storing the integers. I am wrapping with that is wrapper class. This is known as wrapper class. This is the class integer. Okay, we are going to store the integer types in this linked list. Or if you don't mention also, no problem. That will also I will show. So in nums is equal to, you can create a new integers. Okay, new linked list you are going to create. So I will say new linked list. So in this linked list, what I will be going to say is like this. So this is the stuff how you declare an linked list. If you remove this integer, what happens? Let's see. So if you remove this integer, there is no issue. Here also, if you remove these angular brackets, there is no issue at all. But for our sake, for understanding, for clarity purpose, what we are going to store in this linked list, that we are going to have a notation. So that's why we need to mention here the integer. Inside this also we can mention integer, but there is no need. Why? Because we are already mentioning integer here. So that's why it is showing warning over here. If you hover that, redundant type of argument in new expression. So as this is the new type of linked list that we are using, there is no need to mention this integer over here. I hope this makes some sense now. If you remove this, what happens? There is nothing happens. So basically this is meant by that you are creating a new object that is called nums. It is coming from the class called linked list. Okay. So you are creating a new object with the help of this new linked list. I hope you know how to make an object. Okay. So after having this, you can just simply say nums.add. That's it. So you can add how many elements that you want. You can pass integers. Okay, there is no issue in that. And if you pass another integer, nums.add. So basically you can see I am passing both 5 and 9 over here. So there is no issue in this. So after that, what I will be going to say is I will simply print these two, whether those are printing in the terminal or not. What I will say is nums, we will just try to print the nums. So let's see what happens. So if I compile and run, you can see it is showing warning. So the warning it shows, but ultimately it printed all the stuff for me in the terminal. Why it is showing warning? Because it is saying, so linked list okay, it is let me mention the angular brackets here and let us rerun. See, after if you mention the angular brackets again, it is not going to throw this warning also. Okay, if you don't mention this also, there is no problem, but it throws error. So I want to give you the full explanation. That's why without that I gave first. So after that I kept the angular brackets and show you. Inside this we can also pass the integer, but I have already shown that, but it is not required here. Okay, this integer is not required because it's showing warning over here. I hope this makes now some sense. It is successfully printing now, you can see over here. So after that, in this linked list class, we have so many methods. If you hover over that, so it will be going to show you all the stuff. So basically if you go inside this linked list class, you can see explore all this public class linked list. So inside you can see all the stuff. You have a method called linked list, and if you come down you have a method, okay, linked list. Okay, so linked list first you have means you can append the values at the first. Linked list last, you can append the values at the last. So linked list before, so whatever the node you want, that you can append something in the linked list. So that also we will be going to see manually in this session only, how you can append a value in between two nodes. Okay, and how you can unlink two nodes. So unlink last, how can you unlink the last node? So there are so many methods. So you can get last element, so you can just see what is the last element. You can remove the first element, you can remove the last element, you can add it the first. Oh, there are so many methods. So in this video I will just quickly show some of the methods, okay, so that you can understand. So some methods say is I will nums dot, so you can see it is showing all the methods. So I will going to say get first. So okay, in this get first I will put semicolon. So that's it. If you store this, I will say int result, or I will show first, and if I print that, let's see what happens. If I try to print the first, let's see what happens. If I compile and run here, basically it is showing the correct thing, because you have added the first one, that is 5 in the linked list, and you have added the 9 in the next one. So if you see the presentation, basically here that's the stuff we have seen up to now. So how to add an element at the end. So this is the stuff. So if you see here clearly, we are having this node first. So we are pointing head here. So we this is happening beside behind the scene, because those and all things are provided by the Java itself. So after this one, it is we are adding the 9. So the 9 or 6, anything, that is your wish, any number. So after that, it is appending this thing. If you want to append anything, and after that, after this number, it will be going to append here. So like that, we have already seen in the linked list class, there are so many methods that we can. Now in that methods, we have explored one method that is known as get first. Like that, we can, if you say the get last, let's see what happens. If I say get last, so let's see what happens. If I again compile and run, it has to given me 9. So you can see it is giving me 9 output, and finally it is printing the final array due to this nums. Okay. So I hope you understood what is meant by get first, what is meant by get last. You can see here. So with the help of this link, this nums basically is an object. See, this nums basically is an object. So you can object dots, you can call the method. So method name is the get last. You can also say some of the stuff like, I will remove this one. Okay. I will also inside this printing stuff, what I will be going to say is, so I will just say nums dot get. You can also get the index. Suppose if you say get at index 2, so you can simply mention the object dot just get. You need not to mention any get first, get last. You just mention get, and inside the braces you can mention the index. But unfortunately, we have only 2 elements. I will also add the third element, which is an index 2. Suppose if I add 20 here. So if I compile and it has to give me 20. Why? Because 0, 1, 2. Or basically, if you using linked list, this does not make any sense. Because array has index, dynamic array has index, but why linked list will have index? So we cannot say this is the first index, we cannot say this is the second index, we cannot say in this manner. Linked list are not zero based indexing, or linked list as is not any based indexing. Linked list is not indexed based search. So basically it is a search node by node. If you want to search anything, it will go node by node. Let me see what it will be going to get me, what is at the index 2. If I compile and run here, see, it is giving me 20. At this case, it is giving correct, that is at 20. So it is applying some algorithm and giving me at what is index at 2. But don't use this kind of indexing. If you want to check is that 20 is there or not, you can use some of the higher algorithms that may come into picture. Okay. Or if you want to have the highest speed of search, you can use dynamic array, that is array list. That is in Java we call it as array list. You can use that. That will be majorly used in the project and itself. So but in this video, the aim is to show not with the help of this package. I will be going to remove this package for you, and on the top of this class demo, what I will be going to do is I will be hover over that. If you see quick fix, if you click quick fix, it will be going to show some of the things that you can do over this error or warning, that is add import. I don't want that. So create a linked list in demo. I don't want that. So it is saying create a class. Yeah, I want this class. So it will be going to create a class in separate another file, or if you want, you can also create in demo file. That's according to your wish. Okay. So there is no issue. But here it is showing nums.add. So we do not have currently any add function. So I will just remove this for your sake. So if you hover and click, it will be going to, if you want in the demo, you can do that, or if you want other file, you can also do that. So I will be going to remove this stuff here, or so basically I will come to this class linked list. So inside this linked list, you are going to have some stuff that this is the structure that you need to make dynamically. Okay, if you will be going to get some element. So with the help of the object, so in the demo, if I say suppose I am creating a object of nums, if I say something like nums dot add, means what it will be going to, I will pass an integer. Okay. So if I pass, this is the method. With the help of this object nums, you are going to call this add method. So inside this, you are accepting an integer. Okay, this I hope you understood. For now sake, I will be going to comment this. So inside this linked list, you are going to make the structure. Before that, each and every part, this is known as node. We have a data part and we have a next part. You can see over here. We have a data part, we have a next part. The same stuff that I want to do in the top of that. So I will be going to say class, and I will be going to create a new class called node. Okay. This will be going to return a node to this linked list. So inside this linked list, we are going to have main logic so that we can connect all the nodes. But if we need to create every node, so I will say into data. Okay, if I will say into data here. After having the data, you can simply say pointer, that is the node pointer, that we can name it as the next. So there is no issue. This is same as other languages like C, C++. So basically this is a capsule. This will store data. This is single list that we are making now currently. So inside this node, we are making a pointer, next pointer, that is we have named. So I will be going to have a constructor. Constructor name should be name as the class name should be same. I hope you know the stuff. So inside this I will be going to say this dot data is equals to data. Basically this constructor here we can have the int data. This constructor is parameterized constructor. We will accept the data, keep this data inside this data and put the semicolon. Okay, and we are going to keep that next pointer is equals to null. This is the basic stuff. Whenever you create an object, this is the basic stuff. So fill the node by using these stuff. So fill that when you're passing here, if you come to demo, when you're passing new dot add, so add will create a new that node, but that has to fill with this coming integer. Okay, if I come here, the data will come here. Okay, the data will come here. Whenever you are creating a new object, the data will come here and it will be going to store in this data, and the next pointer is initialized with null. If I come to this linked list main class, so inside this what I will be going to do is, so I will be going to say public because that is in the other file. So you are going to say public. So inside this I will be going to say public void. So I will be going to create a function. So function add. Okay, it will be going to accept an integer int data. Is there any issue? There is no issue, I think, because we are passing I commented it. I will remove comments from here. So basically you are calling add function and passing an integer. In the linked list also you are creating a function and accepting an integer called data. So after creating the function, what you can do, you can create the new node, and you can say it as new node. Okay, the name is new node, and you can say an object. Okay, basically you are creating an object of this class. Basic, that is only. So the reference is of node, then the variable name is a new node, and new key with the help of new keyword say node, and in the constructor you can pass the data, because we already know whenever you create an object like this format, and this will be going to call this constructor. So inside this constructor we are accepting the data. Here we are passing data. So this makes some sense now. So it will be going to fill this data with this data. So the incoming data is filled in this data, this variable data, and the pointer will be filled with null. So after that what you can do is, with this new node you can able to do the stuff. You can able to start. So first of all, as you can see clearly, we have a head. Head is pointing to the first node. That purpose, what I will do here is, I will be going to create a head that will be initialized with the data null. So there is no issue in this. Okay, we are having a head that is initialized with null. So inside this if statement, what I will be going to do is, I will be going to check whether this head is equal to null. If that's the case, then I will be going to have the stuff that I will be going to reassign this head to new node. Okay, I will be going to assign this head to new node. So because as we are having this object, we are creating this new object with the help of this node class. Here you can see we have created on the top. So with the help of this node class, we are creating an object new node. So we are assigning the new node to head. You can see in this. So we are assigning this new means we are pointing basically this head to here. Now rather than this head is null, it is pointing to the first node, which is 100. So these two connected. Now to add a new node that so if you say that if head is null, okay, here it is saying head is null, we are going to have a new node. If head is not equal to null, if head is not equal to that some data, so what we can say is head dot next is equals to this one. That's it. Head dot next is equals to some new node. So in that else statement we are going to say that only, but we are going to say in the while loop. Why we are going to say in the while loop? Because so for your simplicity, I have placed the demo.java here and the linked list.java here for more clarity. So in this linked list, we have one class that is node class. So the main class, that is the linked list class. It has also a type. We are introduced the type safety also. So we are having the null here. But inside this inside this while loop, what we are going to check? So we have already discussed about this. If you want to have something a new node inside the end, or if you want to append a new node at the end of this linked list, what you want to do is you want to create a new current pointer which is at the same thing. So the same thing that I want to create a new node which have, so I will say here, so that node name is current and which will be same as head. So there is a issue. I think there is no issue in this. So I created new node. This is basically you are creating an object. So here I am creating an head, that I'm creating an object of node which is same as head. So inside this while loop, what I am going to check is if current dot next. So inside this while loop, I will be going to have the, basically you are traversing all the array, and you are traversing all the linked list, and you are going to up to the end. If current dot next is equals to null, you are stopping and you are coming out of the loop. So after coming out of the loop, what you are going to say is just simply mention current dot next. You are in with this line only you are going to append with the new node. Okay, whatever you are creating the new node here with the help of this node class, just mention the new node. That's it. Our whole job has been done, mentioned like this. So whatever you creating here, just assigning to the current nest. That means, so whatever you are with the help of this current, you are traversing up to the last. So after traversing, you are pointing this one here with the help of the syntax, and you are checking current nest not equal to null. Yeah, here it is null, so we will be going to coming out of this loop. So after that, we are able to join the new node is equals to this statement, the current.next pointing to the new node. This is the thing that how you can add the node at the missed here. We need to print all this stuff, all this on how many addings. We have 3 elements in the linked list. We have added in this successfully, but we are not printing in the terminal. So for printing, I will be going to say here. So basically, it will be going to print all the stuff in the terminal, and I will be going to call this function. So this method does not exist now. If you click on quick fix, it will be going to say you create a method print value in linked list. Yeah, I am very happy with that. So if you come to again to the linked list.java, it will be going to create a method. So in this print values, what we are going to see is we are going to print all the values in the stuff. So for printing all the stuff, you need the current pointer, because you are going to traverse whole the list. So without traversing, you can't do anything. So you can initialize with the head. Why we can initialize with the head? Because if you see clearly, we are having the node, we are creating the node outside this add method only. So we can use as this is the global variable head, we can use inside this print values also. Again, that is initialized with current. So after this statement, what you can do is again for the traversal, you can use the simple thing, that is while loop. So you can also check current here not equals to null. Okay, here in this case we do not head is what, after you are adding 3 values, you can see we are adding 3 values here, adding 3 values more. After adding 3 values, the head is now is at 5, so head is not null here. So after the add function only, you are implementing this print value function. Okay, so after completing this check, and what you want to do is you can print all the stuff in the terminal. So you can simply say s out. So inside this s out, what you can say is current dot data. After that, I will be going to say current increment. So current is equals to current dot next. Basically, with this statement, you are printing all the stuff in the terminal. With this statement, you are going this is not capital, this is small. Okay, so with this statement, you are printing all the stuff in the terminal. With this statement, you are incrementing the current by one by one each element you are going to print in the terminal. So if I come here, if I compile and run, so you can see we have 3 elements. The 3 elements has been printed successfully in the terminal. So this is the way how you can implement manually. You are creating a node, you are creating a separate function for the linked list, and you are going to print the stuff in the terminal. So if you that is 5, 10, 65. So if you want to add something in the terminal, that is example, if I add 100, and if I again compile and run, you can see those and all values are printed, because we are using the while loop here, and we are while adding, we are also using the while loop. So that's why it is able to add all the stuff. How many elements are we are adding, the same and all added with the help of this single if else statement. So that 100, 99, 79 is also printed successfully. So what if you want to remove some elements? Suppose if assume that if you want to remove 5, how can you achieve that? So, or if you want to add 10, not 10, if you want to add 6 in the beginning. So before 5 you need to add 6. So if you simply come here, if you say this statement, this will be going to add the 6 after the 79. It will be not going to add before the 5. If you compile and run, you can also observe that. So we are getting the order as we have added in that. But the 6 is added at the last. But we don't want this 6 to be added at the bottom. We want this 6 to be coming at the top before 5. How can we achieve that? That is known as adding an element at the top. So you can simply cut it here and you can paste it here. But that's not the case. With the help of the code, how can we achieve that? Before seeing that, we need to understand. With the help of this presentation, we have understood how to add at the end. So by this end of the statement, you can able to simply achieve this simple linked list. So where you can have a single straightforward linked list where all the elements has been added. So after that, what if you want adding a node at the first? If you want to add a new node, if you want to add at the first. So in this case, what you need to do is just keep this linked list aside. So with the help of this head and new node only, we are going to have some magic. Here we don't need the extra current pointer as well. So current, you can see with the help of the single line new node dot next. So this is new node dot next. So this will be having the head. So this head will be pointing here, this new node, and inside this new node we are having 100 means it will be pointing here. If you come back, you can see new node dot next. So this is new node dot next is equals to head, means head is pointing to this one. So this node will be pointing to here. So I hope you understood this connection. In this, with the help of these two lines only, you can able to add a node at the. So if you see code wise also, so after this printing values, you can, so before printing only, you can come like this here and you can create a new function. So I will say here only. So I will say nums dot add first, and I will go into pass 22. So there is no 22 here. I hope there is no 22. So I hope this works, but it is showing error because we do not have a method called add first. So simply hover over that, it will be going to ask quick fix. So click on create method add first in the linked list. So it will be going to create a method called add first in your linked list file. So simply remove this thing here. So inside this add first method, what we are going to do is we are going to have some stuff. So you are going to have another node. So say new node. I hope this makes some sense now. You are accepting an integer I and you are passing an integer I. Basically this will trigger this constructor data and it will be going to initialize the data with that data and the next pointer with the null. So if you come here and if you say that two lines, what are the two lines that we have seen in the PDF? That is say new, that's it. Our job has been. If you see here, if you come back, so you can see new node dot next is equals to head. So with the help of this line, you can see you can connect these two. So new node dot next will be pointing here. So after that, you need to make this connection here with the help of this line. You need to make head to here. So you can mention head is equals to new node. With the help of these two lines, we can able to successfully achieve, but we need to have this function before the printing only. So after printing also there is no problem, but it will print and it will not show this add function. So what I will going to do is, so first of all it will be going to have, so I will comment out here for you. Okay, I will be going to compile and run for you. So basically you can see there is no error, there is no issue. It will be going to show you the first element as 5 and the last element as 6. Now I will be going to remove these comments here and I will be going to clear the terminal for you and I will be going to compile and run. Then you can see it is adding 22 at the first because we are passing 22 here. We are passing 22 here. That we have already discussed how to add with the inbuilt Java library which is coming from java.utils. So that with that collections linked list, this linked list also we can import from that object, that linked list class, and we can able to do that. We can add at first, and with the help of this function, our inbuilt function also we can achieve by adding at the first. So it's the same way we can also add at the last. That is homework for you. Try it by yourself. So after this, what we want to achieve is we need to delete the target node having 5. So what if someone came and have saying that you have these elements, they want to delete this in between element. If you see here also, suppose we have only four elements, let's say. So 1, 2, 3, 4. But I will be going to comment out here. Okay, I will be just going to have 4 elements in the linked list, and this 5 is headed with this the head pointer. You can see head pointer is pointing now to the head pointer here we are creating, that will be pointing to this 5. Now basic thing is that you need to delete the value of 65. How can you delete the value of 65? And just you need to print 5, 10, 100 in the terminal. So this has to be deleted. I will write comment here for you, deleted. So this has to be deleted and remaining things has to be printed in the terminal. Now let us understand with the PPT so that you can, how you can simply have your custom function so that you can able to manage the stuff. So after coming here, I will be going to say nums dot delete. So inside this delete the 65. Okay, if you hover over that, you can see quick fix. So click on that. So it will be going to say create a new method delete. It will accept integer. So inside this linked list, so click on that. So basically what it will be going to do is it will be going to create a method here for you. Wait, it is just loading here. Or if it is taking some time, means what you can do is come here, just you can mention void and you can say delete. Inside this delete you can accept an integer. You can say into data. With this data inside that, what see here, error has been gone successfully. So inside this delete method, what the logic that we want to perform is, so again if you come to the slide here, the numbers are different but the logic is same, so just focus on the logic. So these numbers made by me only, but for the slide the numbers are different. For the presentation, for the actual code, the values are different, so there is no issue in that. So you want to delete this one. For that deletion, again you need to have the current pointer pointing to the first one. So you need to make this current pointer to before the deleted element. Here the deletion element is 5, so you need to make sure that current is coming up to this the but1 node. So yeah, with this image you can confirm that you want to delete 5 means you are going to point this current pointer before the deleting node, that is before deleting node of 5 is 8. So you are going to point this current pointer to the 8 with the help of, you can achieve that this kind of situation with the help of this kind of small code snippet. So how can you go from this pointer to the value before node? So simply say current dot next not equal to null. Okay, because if this current dot, if so suppose first of all you are here, so you are, when you are here, the current is here, current dot next points here. So when this is null, you are going to delete the last element, so that's no problem. So and current dot next dot data is not equal to 5 in this case because we are deleting the 5. So what is meant by this? So when you should not go directly onto the 5, you should be on the before but one element. So make sure that you are on the before element, not on the direct element. So that's the stuff I am highlighted with the gold color. So until unless then you are going to traverse whole the linked list with the help of the current is equals to current next statement. So after traversing whole of that with the help of this if condition, you can able to simply cancel this link and you can able to connect directly over here. So you are checking that current dot next is not equal to null, means you are here, current dot next is not equal to null, means you are checking that is this not equal to null. Yeah, if that's the case, what you are going to do is current dot next means here 110 has been upload, means from 110 we are taking from here, we are keeping here. So current dot next. So this is current next. So this is current we are pointing, this is current next, means this is the current next value, and this is the current next value that we are able to assign in the current next value. So I hope this makes some sense. Now we are placing 110 directly here. So this will be now moved to garbage. This garbage collection can be handled in Java by itself by JVM. So now if you see, now the final after deletion, this is the print, the final clean, after clean having this, after you deleting the node 5, it is the clean array of the linked list. Now we are going to understand the same stuff with the help of the code also. So if we again come to the code part, we have already seen how to create a function for the deletion. So inside this deletion, so I again as we already know, we need to create a function called current, which will be initialized with the head. So after creating this node, what you are going to do, again you already know, you are going to traverse with the current value current dot next. So this current dot next should not be equals to null. And we have another condition also to be checked. We already understood with the help of slides also. So current dot next dot data should not be equal to data that we are accepting here. Why? So you can see we are having data only, no problem here, because what is meant by this statement is we all understood in the slides itself. So we should not go with the current pointer, we should not go directly on the node that we are deleting. Here we are deleting the 65, so we should not go directly on the 65. We should be before the but one element, or but one node. That what I am going to trying to say is, so inside there you are going to traverse like this. So you are going to say current is equals to current next. So current dot next, with this statement you are going to traverse all the stuff. So CURL ENT, so don't make spelling mistakes. Okay, after traversing, after you are getting to the last but the deleting but one element, so you just need to check with the help of this if statement, the current, check the if current dot next is not equal to null. If that's the case, current dot next is not equal to null. If that's the case, then inside that you are going to say dot next. I hope this makes some sense. Now you have seen already this stuff in the terminal, as means the PPT as well. Now you are seeing here also. So you can see we are passing 65. Now it will be going, if I compile and run, it will be going to show only 5, 10, 10, and it will be going to show 100. Now let me compile and run. You can see clearly it is not showing 65 in the terminal. We are only deleting 5, 10, and 100. So you want to delete this thing. So what you can do is you can simply come here and you can say 10. After mentioning 10, what you can do, you can just simply compile and run. Sorry, 5 and 100 it is printing in the terminal. So what is meant by that is it is deleting successfully. So we have made the deletion part also successful. So this is how you delete. This is how you make the node function which will creating node. So this is the main class that we are doing all the stuff here. So linked list class, in the linked list class we are creating a normal head pointer. Inside this we are adding at the end. So adding at the first, adding and deleting, and we are printing all the stuff in the terminal. So if you see in the demo class what we have here, we are passing all the values, we are deleting the values. If you want, you can add or come down and you can say nums.add and add first. You can say inside that you can pass 35. Okay, that's the simple stuff. And if you again compile and run, you can see 35 will be added at the first, because you are saying add first. So add first, delete, print, last, add last, these and all, add last here, add one. Again, if I come to the slides, so again one more thing that I want to discuss is if you want to add something in between anything. So the last thing for the linked list is, so what if you want to add back this 5? So we have deleted this 5 in between here. So you want to add between again 8 and 9. So if you see here, we have again current pointer here, last but one here. So as we have seen the logic here, if you see, so with the help of this while loop, what you can going to do, again with the help of this while loop only, you can come up to here. Why up to here? Because you need to add between 8 and 9. So whatever the node you are adding, so before that only you are going to place your current pointer there with the help of this kind of syntax. After coming there, what you can do is you can simply add, okay. So after coming here, you can create a new node. So initialized with the data that you are trying to here is 5. So the next pointer is pointing null. It has some address 105, okay, 105. So with the help of this simple if statement, you can able to check is current.next, means current.next is not equal to null. If that's the case, if this is not equal to null, what you can do is new node.next, means this new node.next, this take this 110 and place it here, means that is current.next. This current.next that is pointing to here, this 110 will be placed inside here. So this link has been successfully completed. Now what you want to do is just break this link and make this in this way. So in this way you need to have, see clearly in this way. So if you see in the next slide, so that's the same thing. So if you come back, the same thing that I am making here, in this fashion you are going in this fashion. With the help of the current.next is equals to new node, means this is current.next is equals to new node. That's it. Our whole job has been done. So this points here, this points here, this points here, completed. You can see this is the way that we are going to achieve the new node of with the value 5 that is successfully appended in between 8 and 9. So I am not going to show the code for this one. So simply up to here you already know. I am giving code snippets here also. You can simply try it by yourself. Assume that this is your homework and try it by yourself. So I hope you understood all the concepts about linked list in this session.